Our speaker, narrator at 1x. Media, colourful laboratory setup with bubbling flasks and beakers. Hey there, science explorers! Media, chemical reaction of baking a cake in a kitchen laboratory setting. Iron rusting experiment in a controlled environment. Have you ever wondered how a cake bakes or why iron rusts? Media, dramatic chemical reaction experiment showcasing transformation. These fascinating transformations, my friends, are all thanks to the magic of chemical reactions. Media, various everyday scenarios depicting chemical reactions in action. In our everyday lives, we encounter countless chemical reactions that shape our world. Media, montage of different chemical reactions in food, air, and other elements of daily life. From the food we eat to the air we breathe, chemical reactions are the backbone of life itself. Media, close-up shots of hands writing chemical equations on a whiteboard, digital animation of chemical equations forming and changing. Now, to understand these captivating transformations, we need a way to represent them clearly and concisely. Media, scientist writing chemical equations on a transparent board in a laboratory. That's where chemical equations come into play. Media, time-lapse footage of complex chemical reactions represented through equations. Think of them as the language of chemistry, allowing us to express complex reactions in a simple and elegant manner. Media, students studying chemical equations in a library or classroom setting. Close-up of a textbook explaining chemical equations. Just like learning any new language, understanding chemical equations opens up a whole new world of scientific exploration. Media, scientific journey concept with chemical equations floating in the air. In this exciting journey, we'll unravel the mysteries of chemical equations together. Media, visualization of decoding chemical equations with flowing text and symbols. We'll learn how to decipher their secret codes and uncover the hidden stories they tell. Media, exciting laboratory experiment with chemical reactions unfolding in real time. So fasten your seatbelts, science enthusiasts, as we embark on an adventure into the captivating realm of chemical equations. Media, close-up of a scientist looking amazed at a chemical reaction happening in a lab. Get ready to be amazed.
Media, animated character demonstrating a simple chemical reaction with colourful animations. Together, we'll explore how substances transform and create new forms of matter. Media, animated character writing chemical equations on a digital board. I'll show you how to read and write chemical equations, making it super fun and easy to understand. Media, animated character conducting a dramatic chemical experiment with exciting results. Let's dive into the wonders of chemistry and see the magic unfold right before our eyes.
Or speaker, narrator at 10x. Media, campfire burning with logs turning into flames, smoke and ash. Let's start our chemical equation adventure by meeting the key players, reactants and products. Media, close-up of hands assembling chemical reaction components like Lego blocks. Imagine you're building a Lego masterpiece. Media, close-up of hands holding chemical reactants before mixing. Your starting Lego blocks are the reactants, the ingredients of your chemical reaction. Media, chemical reaction components combining to form a new product resembling Lego creation. As you snap those Legos together, you create something new, your magnificent creation, which represents the product of the reaction. Media, ingredients being added to a recipe symbolizing chemical reactants. In simpler terms, reactants are the substances present at the beginning of a chemical reaction. Media, ingredients in a pan being cooked and transformed, representing reactants in a chemical reaction. They are like the ingredients in a recipe that get transformed during the cooking process. Media, newly cooked dish being served, symbolizing products of a chemical reaction. Products, on the other hand, are the new substances formed as a result of the chemical reaction. Media, delicious meal being enjoyed, representing the products formed after a chemical reaction. They are like the delicious dish you get to enjoy after the cooking is done. Media, campfire burning with wood and oxygen reacting. For example, think about burning wood. Media, close-up of wood and oxygen as reactants in a chemical reaction. The wood and oxygen from the air are the reactants. Media, logs burning and releasing heat, light, carbon dioxide and water vapor. They react with each other, producing heat, light, carbon dioxide and water vapor. Media, chemical reaction products like heat, light, carbon dioxide and water vapor being produced. These new substances are the products of this chemical reaction. Media, transformation of reactants into new substances in a chemical reaction. See how the reactants transform into something entirely new. Media, chemical reaction showing the creation of new products from reactants. That's the magic of chemical reactions at play. Speaker and narrator at 10x. Media, balance scale with Lego blocks demonstrating conservation of mass. Now here's a fundamental principle governing all chemical reactions, the law of conservation of mass. Media, chemical reaction in a laboratory setting. This law states that matter cannot be created or destroyed in a chemical reaction. It can only change forms. Media, close-up of hands assembling Lego blocks. Think of it like a game of Legos again. Media, time-lapse of Lego blocks being assembled and disassembled. You start with a certain number of Lego blocks, and no matter how you assemble or disassemble them, you'll always have the same number of Lego pieces in the end. Media, chemical substances being weighed on a balance scale. Similarly, in a chemical reaction, the total mass of the reactants always equals the total mass of the products. Media, close-up of atoms rearranging during a chemical reaction. Atoms, the tiny building blocks of matter, are merely rearranged during a chemical reaction. Media, visualization of atoms rearranging in a chemical reaction. They don't simply vanish or appear out of thin air. Media, wood burning in a controlled environment. Let's go back to our wood burning example. Media, comparison of mass before and after wood burning reaction. The total mass of the wood and oxygen before burning is equal to the total mass of the ash, carbon dioxide, water vapor, and other products formed after burning. Media, atoms rearranging to form new substances in a chemical reaction. The atoms present in the reactants have merely rearranged themselves to form new substances. Media, close-up of balanced chemical equation on a whiteboard. This fundamental law is crucial in understanding and balancing chemical equations, ensuring that our representations of chemical reactions are accurate and reflect the true nature of matter. Speaker, narrator at 10. Media, close-up shot of a whiteboard with the law of conservation of mass written clearly. Now that we've met the key players and understand the law of conservation of mass, media, video of a chemical reaction taking place in a laboratory setting with symbols and formulas displayed on a whiteboard. Let's dive into the language of chemical equations. Chemical equations are like shorthand notations for chemical reactions, using symbols and formulas to represent the substances involved. In a chemical equation, the reactants are written on the left-hand side, followed by an arrow pointing towards the products, which are written on the right-hand side. The arrow represents the direction of the chemical reaction, indicating the transformation of reactants into products. Media, close-up of a whiteboard with the chemical equation for the formation of water H2O from hydrogen gas, H2, and oxygen gas, O2, written clearly. For example, the chemical equation for the reaction between hydrogen gas, H2, and oxygen gas, O2, to form water H2O is 2H2 plus O2 yields 2H2O. Media, close-up shot of the chemical substances involved in the reaction, H2 and O2 arranged on a laboratory table. In this equation, H2 and O2 are the reactants, H2O is the product. Media, video showing an arrow, drawn on a whiteboard to represent the direction of a chemical reaction. The arrow indicates the direction of the reaction. Media, close-up of a whiteboard focusing on the coefficients in a chemical equation, illustrating the relative number of molecules involved. The numbers in front of the chemical formulas are called coefficients, and they tell us the relative number of molecules involved in the reaction. Media, video of a teacher explaining coefficients in chemical equations using visual aids in a classroom. We'll explore coefficients in more detail in the next section. Media, close-up shot of a textbook open to a page displaying various chemical equations and their meanings. By understanding the symbols, formulas, and conventions used in chemical equations, we can unlock a wealth of information about chemical reactions